Well, you remember I had these problems with the electrical supply system, so I decided to tackle that first. And basically, what I decided to do was to try and create a single wire that would take all of the current and a single ground wire, rather than trying to chain it through all of the breadboards. So what I did was I measured it out and basically soldered together the wires so that I could feed a single supply straight into the breadboards without it being going from one breadboard to the next breadboard to the next breadboard. It all just travels down the same wire and into the breadboards. So that's worked out much better. And because I'm using HT chips rather than LS chips, I got enough current just from the USB 5 volts and the amperage from the supply from the USB. So that was tested with a multimeter, and that seems to be working pretty good. So luckily, the power was relatively straightforward and easy to fix. It just took a little bit of time to solder all the various bits of wire together. And you can see it here running around the outside. So I'll go through the whole board for you just to reiterate where I was. This is the way it was just after I finished the power supply, and you can see that it goes straight into a USB power. So it's a single wire basically for power and a single wire for ground, and then it branches into the breadboards. Basically every other breadboard. Now here I've put in a crystal for a clock because I'm going to replace the timer, and up there I've put the zero counter, the checker for compare, and then the flags. Then the next board down is the adder, and the two adder chips are under that white wire, and it adds the A and B operands, and then those feed into the carry flags, etc. on the board that I just showed you. And these are the chips for the A and B operand, and they just feed the chips in, or they do shift left or shift right or pass through. And on the A register it'll do a 0 or a 1 if you need to. Now down here I've added this new chip, and this is a compare chip, and it compares two 8-bit values, and it says it's either 0 or greater than. So this is the new chip that I'm going to use for comparisons. So the CMP command when I do the assembly language, and it just says whether P is greater than Q or P is equal to Q. And it's much easier than what I was going to do with a load of logic chips at the top of the board. So this takes care of everything. Then the next bit here is the logic units. It does AND, NOT, OR, XOR on the A and B channels. And it needs to have the memory channel as well. Now this is the operands. So this next board is the reverse clock timer and the memory address register and the operational pointer. And then this one is just the memory register. So this is the RAM, the memory data register, and the two A and B operands that I'm going to use for memory. And then this is the bit I just finished that displays the value, and at the moment you can see it's plugged into the data bus, so it's just going to show you whatever is on the data bus rather than any register. At the top, the one on the left, the three chips on the left are the program counter, and the two on the right are the stack pointer. And then this next one is the register 1 and register 2, and they feed into the data bus. Now, none of these have the clock applied yet. This one is the I operand, and you can see the yellow wires going over into the logic unit. But those chips there, those 4 chips, they just select register 1, 2, 3, or 4 to go into the A operand. Now this is registers 3 and 4 here, and they're just a duplicate of the one at register 1 and 2 above. And this is the B operand select. So here you can see the yellow wires going over to the B operand that goes into the ALU. And it's the same deal, it just selects which register, 1, 2, 3, or 4. This is where the operating byte codes is going, and this particular one controls just about everything on this right hand side, and this second one controls everything that's going on in the left hand side, and I've got one spare line left only on that one. Now this is the current timer, but I'm going to get rid of it and replace it with the thing on the top left, with the crystal, the 1 megahertz crystal. So what I'm going to work on next is these bits of memory need to be going into those yellow wires, the A and B operand. So I need to wire those up. After that, I need to get the A and B operands into this comparison chip, and then have a bit of a think about how that's going to interact with the assembly language or the assembler I'm programming. And here, this is the clock. I need to replace this one down below with this here and get the single step clock working as well. I'll probably work on that before I work on anything, the rest of it. This comparison chip and the chip at the top that it's pointing at for the adders, it also does a check for 0. That gives me 2 comparisons, and it's causing me a bit of a headache in the software because I don't know how I'm going to do that. You can see from this chip that there's no enable pin, so this thing is always outputting the result if P is equal to Q or P is greater than. So I don't really know how that's going to work in the software yet. That's causing me a bit of an issue, and I have to have a think about it. So I'm not covering any software here.